So the question might be, why am I bringing up this fraction business as a minds-on? You're going to be seeing stuff like this as we do algebra, and I need you to be comfortable not only with fractions, but also with getting rid of fractions. Like if we were doing reverse BEDMAS, so algebra, how do you get rid of a division of 2? You'll times by 2. But a division of 2 is the same as multiplication of half. So how do I get rid of a multiplication of half? I can times 2. So it's a little bit funky, but instead of trying to memorize this, maybe I'll try to give you another tip instead by doing some of these example questions. Okay, so please, would you turn to our handout and go to our very first question together? You will see this as your first. Yes. Half is the same as 0.5. Yeah. Times 2. Oh. It equals 1. That's how we make it go away. We turn it into a value that won't change even if you multiply with something else. I guess. You know, I would rather not just, I would rather you think about it as fractions. Take a look at this. Ready? Just as our mind's on, 1/2 multiplied by this, I could rewrite this as 1/2 multiplied by that, just like before. That bracket, you can think about it as over 1. And so using that as my argument, I think a lot of people would feel more comfortable if I rewrote the question above like this. I mean, I could be wrong, and you can tell me that. But once we get to this point, things might seem a little bit more familiar. Reverse BEDMAS. I'm doing brackets last. How do you get rid of a division of 2? And so I'm going to go through all the steps, okay? So if I multiply across, the left side becomes 2 times x minus 5 over 2. The right side equals a 4. But some of you might already be simplifying because you're pretty comfortable with fractions. A 2 in the numerator, 2 in the denominator, they divide each other. What does that simplify into? So x minus 5 equals 4. Add 5 to both sides. I'm going to jump this step because I'm not going to insult intelligence. I know that you've practiced. So x equals 9. Bottom line, you'll see this again and again. If there's a fraction, let's get rid of it. I know I say that lightly, but I know it might be, I also know it might be a little challenging for some. Let's do it again. I'm going to rewrite this fraction like this. It'll be easier to digest. Oh, come on now. I expect you to know this part by now because of homework. You add 5 to both sides, right? I want to get rid of the negative 5. I guess I could do this. I could leave that there. Same thing. Again, oh, Mr. Ken, I don't want to deal with brackets or fractions. They give me anxiety. I just don't like it. Okay, I spit on fractions all day, every day. I don't know how you express your disdain for fractions. Okay, but I do see it as a division of 4, not just a denominator. Think about it as a division of 4. How do you get rid of a division of 4? I'm going to multiply both sides by 4. The left side becomes 28. The right side becomes just plus 2, which I don't need the brackets for because you multiply. Oh, and could you grab a piece of paper for today? Yeah, grab today's lesson, please. And then again, at the end of the day, that's a +2, so -2 on both sides. This becomes 26. That's it. That's it. Any questions? Some people really didn't like simplifying too early. Some people just did not enjoy this reducing process. But if those of you here find that's pretty natural, then that's great. Any questions? No? All right. Let's try. Yeah. I'm going to try E. C?
Yeah.
Okay. Interesting. Might as well end up doing everything.
Yeah.
Because you got some time. All right. Let's see. You can assume that there's a bracket there because the numerator, get into a habit. You can't touch the numerator until everything around it has been sort of resolved. Okay. I mean, you could, but I think there's more room for careless errors unless you know what you're doing. So I see a division of 4, and I don't like fractions. So let's get rid of it. So division of 4. What's the opposite? Yeah. Yeah. So this would be x plus 1. That's all divided by 4. But I'm going to multiply by a 4 on both sides. Okay. I'm not sure how many people are comfortable with me. Just nod your head or shake your head. It's fine. Who is comfortable with me doing this? Are you comfortable? Everyone's okay? It saves me from writing a step. That's all. I'm just lazy by nature. Never mind. I will revoke.
No, it's okay. I just want to know why you do it.
It's because I wouldn't have to write this next step. Because I know it's 4 times the numerator, and then the denominator is still a 4. And they will reduce to become 1.
Oh.
And so if you see that that's going to happen anyways, you just sort of mentally know that will happen and you skip that step. But that's okay. Subtract 1 to both sides. The final answer is 35.
Is it 36?
9 times 4. I can take this 9 and I can multiply by 4 to both sides. Same with this next one. Okay. I'm going to set up D so that you could try E. Please note E doesn't have a very nice answer. B is some kind of weird fraction, but that's okay. Give it a shot, all right? D. Having a fraction like this doesn't change the method. 2 multiplied by 5 minus x over a 3 equals a 2. Transform it into a form that makes you comfortable. And then get rid of it, of course. But see if this makes more sense. I feel like people would like this more than they would like the one above. But that's just a hunch. I'm going to multiply both sides by 3. Take a look at how I'm skipping steps here, or I'm not writing anything. If I multiply both sides by 3, the numerator will disappear with the denominator will disappear by multiplying by a 3, and a 2 becomes 6. Next, instead of dealing with the bracket, reverse BEDMAS, I'm going to multiply, or I'm going to divide both sides by 2. And I just said, I'm going to divide both sides by 2. I'm going to stop there for a second. Some of you might have wanted to do something else. Did any of you have a different idea? Okay. Thank you for mentioning that. Who's right? I mean, as long as you're doing the math, following the rules correctly, you could do it in any order you really want. Let me explain. I'm going to do it my way. I'm going to divide both sides by 2, giving me 5 minus x equals 3. I divided both sides by 2. And then to get x all alone, I'm going to subtract both sides by 5. 3 minus 5, that's a 2. And of course, x right now is being multiplied with a -1. So divide both sides by a -1. This becomes x equals 2. That's my final answer. Abby, on the other hand, decided, oh, there's a number in front of a bracket. I remember this. I'm going to do distributive property. 10 minus 2x is equal to 6.
Why can't you do that?
Could. Who says you couldn't? I'm trying it, right? And how do I get the -2x? Remember, reverse BEDMAS? I see. I got it. I see the 10. I want to get rid of the +10. So subtract 10 from both sides. This becomes -2x, 6 minus 10, -4. How do I get x all alone? Right now, the x is multiplying with a -2. Divide both sides by -2. My final answer is 2. Same as before. And this is the thing. You will see as you graduate and get higher and higher in maths that there's going to be more than one pathway that you can actually take. But as long as you're doing your steps correctly, like the mathematical calculations correctly, you will all end up at the same location. So yes, you only have one answer, so to speak, in mathematics, but the process to get there is what math is so, that's what math teachers are more interested in, and how you actually got there. So you have to be able to show your work. You have to be able to think for yourself. You have to be able to do things on your own and not just listen to me. And the way you do it, it will evolve based on your practice. I can hear it. Owen, please get off your phone. You've been looking at it ever since I told you to pick up the paper. Let's try it. Any questions on this? Would you like to? I wanted to save that so that you can try it on your own, but okay then. Let's try 8. I'm gonna go through it as if I was doing this on a quiz. Okay.
2b 6. No. Yeah.
Okay. You know what? This is Angus's world. Okay. I'm gonna do distributive property first, and as long as I'm doing distributive property first, should be okay. 2b minus 6 over 5. Nope. The 2 is part of the numerator. It's just multiplying that bracket. Next, remember, I don't want to touch that numerator. Okay, I have a division of 5 going on. I will multiply both sides by 5. 2b minus 6 equals 15. Correct. As long as you're doing whatever you're doing correctly, you'll see there's more than one way to get there. Reverse BEDMAS, again, constantly reverse BEDMAS. Now that the bracket is done, this is a bracket. You don't need the bracket anymore. So look at it with fresh eyes. Let's get rid of the subtraction. It is plus 6 plus 6. The final answer is 21 over 2, which is a 10.5. So again, no guesswork. Can you imagine trying every number possible until you get a 10.5? No, right? That's annoying. Algebra removes the trial and error aspect of it. It removes the guess and check. reverse engineering it. Whew. We're going a lot smoother than our previous class. So I'm not sure if it's because you understand it or if you're just shy on asking
On
questions.
our test, can we say E is 10.5?
You leave it just as is. You don't even need to plug it into the calculator.
You should go through.
Sure. I like the fractions more though, so if you want to make me happy. Anyways, do you have a question? Okay. If this is okay, then we're ready for the final sort of hurdle. If this is not, put little stars next to it and write out what you think is an issue with you. You're like, I have no idea how we got to here. Just put a little question mark and address it later. Okay? Don't leave it and be like, oh, I'll look at it another time. Maybe I'll get it then. No, just figure out exactly. Oh, notice how the fraction is gone? I multiply both sides by.
But what happened with the
That's what I mean. It's a division of 5, so I multiply both sides by 5. Yeah, I did this. Ready? I multiply both sides by 5. So this will, they will reduce to 1, so I don't have to worry about that. 3 times 5 is 15. Okay. So part 1, so this is essentially the main lesson for today. I'm going to throw both of it at you. I think you can handle it. The second, the back page is like, okay, so now we have a fraction on one side. What if we have a fraction on both sides? As always, there's more than one way you can do this, but I'm going to stick to one way until people get a little bit more comfortable with it. If you have another way you want to run it by me, absolutely. Okay. But the best way, when you want to deal with fractions, yeah, you have to multiply. Do you want to multiply with a 10 or multiply with a 5? If you multiply with a 5, great, this one's gone, but that one still will be around. How about we look for a number that when we multiply, it gets rid of everything at once. When you have multiple fractions like this, what you want to do is find the lowest common multiple. What number can divide by a 5 and a 10? Divide by. Yep. Too high. Yes. Think about it. 5 times 2 is a 10, and 10 times 1 is a 10. Both of these numbers multiplying into a 10. That's the smallest number. So here's what you do. Take these fractions. Let's multiply. This. Multiply by the lowest common multiple. So I'm going to show everything, okay? Because it's the first time. The numerator becomes well, we'll have this multiplied by 10. I know it will. I'm just trying to show everything. So remember, this is 10 over 1, right?
Oh, it's 10 over 1.
And this is also 10 times 8x over 5. I'm just rewriting it. It's the same thing, right? Here. So I wrote the 10 in front of the bracket. I wrote the 10 in front of the bracket. And the reason why I wrote it this way for now, I'm probably going to skip this step a little later, is 10 divided by a 10 is going to be just 1. 10 divided by 5, what does that turn into? So the left side is x plus 1, and the right side is 16x. Hmm? 2 is still multiplying with 8x. Because 10 over 5 is a 2. So let's bring all the x's to one side. This, I'm going to bring it all to the left side just because. And I'm going to bring all the numbers that do not have a variable to the other side. I jumped the gun a little bit. See if you follow that. I'll pause the video and let you sort of sit in it for a little bit. Try the other one. Same as before. I'm going to clear this. Can I move more to the right? All right, there we go. Yes. Yes, it is. Even before I asked, right? What is the lowest common multiple that can help me get rid of the denominators all at once? Too big? Just 6. Multiplication tables. So, right? Multiplication tables 3, 6, 9, 12, 15, 18, blah, 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 blah. Multiplication of tables for 6 is 6, 12, 18, 24, 30, blah, blah, blah. Correct. Lowest common multiple. Yeah, it has been a while, I'm not going to lie. Right? I'm going to multiply both sides by a 6. I know this is going to be a bit rough. Let's continue to work through it. X minus 1 over 3 is going to multiply to 6. Let's write the next one. If this was normal fractions, multiply the top. This would be 6 times x minus 1 all over 3. And this would be 6 times x all over 6. I know it looks funky, but take a look at the next line. It's going to get rid of all the denominators. 6 divided by itself is just 1. So this is going to be just 1x. Look how clean that looks compared to this. What about the right side? 6 and the 3. What would that reduce into? Six divided by 3 is a 2. So the left side is 2 times x minus 1. So this fraction became 2 times x minus 1 equals x. And this portion should look familiar from yesterday's homework, assuming you've done it. Right? What do you do when you have a bracket? You could, yeah, let's do distributive property. 2x minus 2 equals x. I'm going to bring this x to one side because I want all the x's together. I'm going to add 2 to get rid of this negative 2. So the final answer becomes 2x minus x equals a positive 2. X equals 2. I brought the x to this side. Right, minus x minus x. Yes?
X and 1x are the same thing, right?
Correct.
If you wrote 1x equals 2, right?
Correct. However, this thing, it's a waste of your pen stroke. And as a mathematician, I encourage you to be lazy. That sounds really weird, but it's a convention where you can assume 1 and the known number in front. Same thing. Quick recap as people are copying. Number 1, look for a lowest common multiple, multiply both sides, then all of a sudden you will get rid of the denominator, and the rest is previous practice of algebra. So this part is new today. Top couple lines. Are you ready for C? I'll give you a minute. While I upload the answer key for today. Pardon me? Oh. Oh, wow. Oh, yes, thank you. So step one, lowest common multiple. Step two, multiply both sides by the lowest common multiple. Step three, simplify to get rid of the denominator. Once you do that, the question will look awfully familiar, like some of the other previous questions you've done for me. Oh, this is still part of algebra. If you want to title it, call it 3.7, solving equations with fractions, or solving fraction equations. All right, let's try it. Here we go. Not gonna lie, I'm sort of excited to show you this last example for C. I will let you try, you know what, C and D, I'll do C. The reason why I'm so excited to show you C is because you might see something familiar that you might have done from like grade 4. And I hope that you make that connection and feel encouraged by it, but here we go. Common multiple between 4 and 5. Thank you. So I'm going to multiply both sides by a 20. Not inside the bracket. Oh yeah, absolutely. You know what? You're right. Why did I think of that too? Thank you for being in my class. Don't get too cocky, right? But like, yeah, that's a really good idea. Multiply both sides by 20. Like, I don't know why I didn't do it in the first place. Because if you do that, you already know what to simplify. 20 is being divided by a 4. Me with the 5. And 20 divides by a 5, leaving me with a 4. But here's the thing. Before we go any further, do you recognize something between this and that? What did you just do? What happened? You switched. And you remember this thing called cross multiplying? And the teacher just said, oh, take the denominators and switch them. Right? Just bring it back up. What they were telling you to do was this, but without any of the steps. And so it makes absolute sense that you come up to grade 9, you're like, oh yeah, cross multiply. I don't know why, but I'm supposed to do it. There's a reason behind it. And cross multiplying is a shortcut for finding the lowest common multiple, multiplying both sides, because that's what you do in algebra, right? It's equal sign. And then simplifying fractions. I hope you understand why your elementary teachers chose to do the shortcut, because it's a little too much work. But at the same time, if you believed math was just a bunch of magical steps that you have to follow, and if you didn't, you get it wrong and you get in trouble, I hope that you will be comfortable breaking those bad habits you might have developed. Math isn't just magical steps. There's a logic behind everything that we do. It's one of the only courses in school, I'm going to say, because I'm biased, that forces you to think for yourself, that think deeply. The only other course, in my opinion, that forces you to think for yourself and think deeply is like things like politics and English, right? You need to see history, for example, and try to understand why the heck did they make the decision to invade? Because that's not rules that they follow. That's a firm decision that they made. going to World War II, right? They made a firm decision. Same with math. It's not some magic. There's a logic and a thought behind every single step. So I hope that you will, be a little bit more encouraged and look, okay, I can think for myself. I could do that, and try to approach this with baby steps. All right, let's continue on. Now that we have this, you might start to see that as familiar from yesterday's lesson. Then, did you want to continue?
I just wanted to ask, what was the answer for?
A 1/15. It's a very weird fraction. Okay, let's continue. If you see this, I hope you find it familiar. This is 5K plus 35. This is, yes?
Not in my conference.
Huh?
Not in my conference.
Yeah, at some point today, I hope. Yeah. Great. Moving on, 5K, 4K. I want to bring them to the same side. I'm going to subtract both sides by 4K, leaving me with K. I don't want the 35 there. I'm going to subtract both sides by 35. This is negative 47. Done. Once again, can you imagine trying to guess and check until you got the right number? Algebra removes that. It's trying to reverse engineer so you never have to do that ever again. Okay? This is it. I want to give you that opportunity to try this by yourself here, but I'll try to lay it out. Okay, step one. See, you find the lowest common multiple, and then you multiply to rid the fraction, right? Get rid of the denominators. And then the rest is just expand and simplify. That's it. So I hope you can give this a shot. The answers to this entire sheet, plus the questions on the very last page, the answers to all that will be uploaded in just a moment. So please be patient. Otherwise, the rest of class is yours. Please keep the discussions to a minimum, right? And get to work. Yes?
Negative 27 is that 35 plus negative 12?
Negative 25 minus 35, because I'm minus the 35. Yes. Next Friday. Yeah. Think about it like this. What we're doing right now is essentially the last bit of the mechanics. All of next week is going to be learning to use it in word problems. So hopefully the word problems don't give you fractions, but if they do, this is how you deal with it. Question? Let me stop this.